Here, so let us talk about the last lecture of this chapter, that is a kinematic equation for a uniformly accelerated motion, right? So kinematic equations for uniformly accelerated motion, right? So this equation is what it says, that we are going to derive some equation which is for uniformly accelerated motion. So it means that the acceleration is uniform, it is not varying in time. So first we will use the graphical method. Right? So what is graphical method? So we are assuming that there is an ET graph, right? And it is something like this. It says O, A, where it is V naught, and this is your, this is V, right? And this is V minus V naught, right? And this is T. This can be written as B, this as C, and this as T. Right? So this is your velocity time graph. Considering that the object started time t equals to 0 at with velocity v0 from a point A, and reaches at point B with certain velocity v. Now it is asked that how much accelerated it is and what is the displacement it has, right? So let us calculate it. First we will use the graphical method, this method. So using it, let us calculate the slope of the graph, this, the line AB, slope of the line AB. AB is nothing but the acceleration, right? Is equals to A, the acceleration. Acceleration A is equals to how much? It is V minus V naught divided by T minus 0, right? So A, which gives you V equals to V naught plus AT. That's the first equation, right? Equation A you can write. So this is equation A, right? Now to let us, let me write it one rather than, that will be more useful, more clear. Now let us calculate, as the velocity time graph represents acceleration, or let us calculate the area under the graph. Area under the graph is nothing but the displacement, right? Is how much? It is area of triangle ABC plus area of this quadrilateral OACD, right? So you have area of triangle ABC and area of OACD, right? Which is a quadrilateral, right? It is a rectangle obviously, because this side is equals to this side and this side is equals to this side. So what is the area? It is half V minus V naught multiplied by T0 minus T, right? Right, this is the area of the triangle, half base perpendicular, so perpendicular multiplied by base either way, plus this multiplied by this. So what is this? This is T and this is your V naught. Right? From here to it is V naught, here it is V, so this is V minus V. So what exactly we have got is this. So V plus V naught divided by 2 into T. This is what we are getting, right? And this is what it is displacement x. Right? So x equals to V plus V naught into T divided by 2. Now what is T? If you look at it carefully, right? T is, so let us simplify it further. So just remove this thing. This you can say that equation number 2 is there for now, right? Now the equation number 2, if you write it this thing, if you replace T, you replace from here also, you can replace B minus B naught by AT. So if you put here, rather than writing this for now, you can write it half B minus B naught is nothing but A T, then multiplied by T plus B naught. So it gives you x equals to half AT square plus B naught T. That is equation number 2. Right? Now this is equation number 2. Now let us simplify this and again start with this equation. So rather than write this as 2 and write this as 3. Now again start with the 2. Again starting with the 2. Right? Replace T, which is equals to x equals to half V plus V naught into T. Now replace T by using equation 1, which is V minus V naught divided by A. Right? So half V naught plus V into V minus V naught divided by A into T, right? This is what you find from equation 1. Now this can be further simplified, right? So what do we get from here? You get it half B naught square minus V square divided by A, right? So it means that, which implies that V square equals to V naught square plus 2 times A into x, right? So this is your third equation. Now these 3 equations are called the equations of kinematics, right, for uniformly accelerated motion, right? Now we will go to another method which is called the integral method. So this is for the one where time varies continuously, right? So sorry, time varies within a larger interval. When there is a constant change in velocity, then you use the time in the smaller interval. In that case, you will take this integral method to calculate these equations, right? For continuous changing velocity, the time interval, which is called your instantaneous velocity. Now here we are taking an average. Now we will go to the instantaneous, because we are assuming that in 0 to t time interval we must be 0 naught is constant, right? And for large interval, the change in velocity is constant. Now we will go to the graph, this integral method. So let us go to the integral method to calculate these equations. So we will start with the right. So integral method. So what is the integral method? Or basically a calculus method of calculus. Using calculus. So now we will discuss the method of calculus, right? So method of calculus. Right? So we will use what we call for a uniformly accelerated motion, we use instantaneous velocity. A equals to dv by dt. So let us assume that at t equals to t0, v equals to d0, and at t equals to some t, and v equals to some v. Right? This is general case. So you integrate it 0. Sorry, this is v naught, right, to v dv equals to t0 to t a dt, right? This equation is there. It's a simple integral. It gives you v minus v naught equals to a times t minus t naught. Right? So what exactly you get here is v equals to v naught plus a t minus t naught. Remember that when t naught is 0, or an object is starting at t equals to 0 with certain velocity v, then it will become v equals to v naught plus a t. This is our equation 1. Now we want to calculate the displacement, right? So how we will calculate the displacement? Now we know that as displacement dx is defined as v dt, right? This is just from, or you can write it another way, or v equals to dx by dt. It's implying, so dx equals to v dt, and what is v? It is v naught plus a. It is v naught plus a t minus t naught, right, dt. Now just again integrate over, assuming that at x is 0 to x, dx equals to T varies from T to T naught. Right? So how much you are getting? You will get T naught T V naught plus A T minus T naught dt, giving you how much? It gives you V naught into T minus T naught, right? And then A into T minus T naught whole square divided by 2. Right? This AX dx is S square by 2. Right? This T minus T naught. This is what you are getting. So this is x equals to, x minus x naught. Giving you x equals to x naught plus v naught so this is what we have got. This is your equation number. This was 1. This is your equation number 2. So you see, using the method of calculus, we derived equation, kinematic equations, the equation 1 and 2. Now we will go to the equation number 3, right? So how we can derive the equation number 3? So you write dx is equals to v dt, right? Sorry, not this, rather than acceleration is defined as dx by dt, dv by dt, right? We are trying to find a relation of acceleration with displacement. dv by dt, which can be written as by chain rule of differentiation, dv by dx into dx by dt. Right? This is what we call chain rule of differentiation. Let's put it into adding the and removing. So this gives you dv by dx, and dx by dt is nothing but v. Right? So it becomes v dv by dx into, right? v dv divided by dx. So a dx is integral v dv. Right? Now just simplify it by putting the integral x naught to x and v naught to v, gives you v square divided by 2 with a limit v naught to v equals to a into x minus x naught. Right? You further simplify it. What you find here is it is b square minus b naught square equals to 2 times a into x minus x naught. So this is the equation we are finding. It means that v square equals to b naught square plus 2a x minus x naught. So remember that this x naught and these all which are coming here are by assumption that at time t equals to 0, your displacement is finite. So the particle is now starting from the 0 point. It already has some displacement at time t equals to 0. It is just like this. Right? it already had some displacement at time t equals to 0. So this is what we have. So this is all we have in the kinematics. We derived, we started with the velocity, displacement, velocity. We discussed problem on it. We also discussed about the acceleration, and then on some problem on it, and then we discussed the equation of kinematics, how to derive them. And this is all we have in this entire chapter. In the upcoming chapter, we will discuss about in the upcoming lecture, we will discuss about the next chapter. Right? So please do like, comment, subscribe, and share. If you have any particular question or you want to ask, any doubt, you write in the comment section. We will try to address. Thank you.